So now we'll talk about turning points. Alright, so as you can see here, I have a quadratic graph, and you can see a point there, point A, where it's actually at the top of this graph, right? So if you think about it, this curve does have a lot of gradients, no matter depending on where you are, right, on the line. And if you go up, the gradient starts to decrease and decrease and decrease, and at that point, the gradient is 0 because it's perpendicular. I mean, it's parallel to the x-axis. That's where the gradient is 0. The slope of it is nothing. There's no slope, right? And as you know, dy dx is the gradient, right? So if you differentiate this equation of the curve, you'll get a generic gradient function for the whole curve, right? And if you sub in the values of a certain point, you'll get a specific number, the gradient at that point. And at this point, at A, you know that the gradient is 0. Therefore, you can conclude that dy dx, when you sub in the values of A, equals to 0. Alright, so this is, as you can see here, it's a maximum point, right? Because the curve is going like this. It's a sad curve, right? Where if you draw a quadratic equation, the front of it is negative. Let's see on this curve. So you can see this is quite different. This is a maximum point. This is a minimum point. It's the lowest part of the curve. But the same thing still holds. The gradient here is still 0, right? So the dy dx is also 0. So when dy dx is 0, you can conclude that that's where your turning point is, your maximum or your minimum point. So that's all about turning points. So the general rule of thumb is, at maximum or minimum point, also known as turning point, dy dx equals to 0. So you can use this fact and sub it in to solve some questions. For example, I have this equation, y equals x squared plus 2x plus 5, right? And now I want to use this information to find the turning point. Okay, I haven't specified whether it's maximum or minimum yet. I'll show you later. But for now, please find me the turning point. How do you do this? First, you have to differentiate this equation. You get this, which is a gradient function, right? And now, you don't know the values of x. You want to find the coordinates of x to find the coordinates of y, to find the coordinates of the turning point. But you know that at a maximum or minimum point, your dy dx equals to 0. So I sub that in here. So now I have 2x plus 2 equals to 0. And this is just a linear equation. So I just just shuffle it around and find that x equals to negative 1. So you can conclude that at the turning point, x equals to negative 1. So you can sub this information back into the original equation to find the values of y, 4. So now you know that the turning point of this equation is negative 1, 4. Right? So just by using this information and the fact that dy dx equals to 0, we already found the turning point. So that's how you use this to your advantage. Okay, so this is all about turning points. How do you know specifically whether it's a maximum or minimum point, since they both equal 0? That's where second order differentiation comes in. Look at this graph. This is a cubic graph where there is a minimum and there's a maximum point, right? So if I do dy dx equal to 0, I'll find that I have two answers. So let's try it out. X cubed minus 3x, I differentiate it, I get this. And at the turning point, dy dx equal to 0, and I get this. Then I solve it, I move 3 over there, divide by 3, and I square root it. I find that x equals to plus minus 1. So I have two answers. I have x equals to 1 and x equals to negative 1. So how do you know which one is the maximum, which one is minimum? That's where this comes in, second order differentiation. It's basically just differentiating this equation again. So if I differentiate this, move this to the front, I take this away, I get 6x. Next, you have to sub in the two values, one here, into this equation, right? So I sub in 1, becomes 6. The other one becomes negative 6. And the shortcut is, if this value of the second order differentiation is more than 0, then it's a minimum point. But if it's less than 0, then it's a maximum point. Alright, so this is my minimum point, x equals 1, and my maximum point is x equals to negative 1. Right, so this is all about second order differentiation as well as maximum, minimum, and turning points.